To represent them in the diagram, the Venn diagram is going to be like this, such that the two circles are not what overlapping. So one can also say, if you don't give this relation, that partition of a set is a collection of subsets of a given set, such that the subsets are non-empty sets. You can also say that partition of a set is the breaking of a set, because this set, look up, this set A has been broken into two parts. It's the breaking of a set into non-overlapping subsets. Are you there? Into what? Non-overlapping what? Subset. Full stop. So seeing that there are non-overlapping subsets means that they don't have any elements in common. Alright. So given set A equal to 1, 2, 3, and then the set A is partitioned into two sets, set B and set C, so that set B and set C are subset of what? A, right? So the collection of this subset is what called what? Partition of what? Set. Now let's see if this partition of set, if this three conditions satisfies this. If the partition of set behavior satisfies these three conditions, number one condition is that each subset is a non-empty set. That means none of them should be a non-empty set, should be an empty set. I need to say. Then number two is that no subset should have any element in what? Common. Two or more subsets should not have any element in common. So you can see that set B and set C do not have any element in common. Then lastly, every element in the given set, which is set A, every element here should belong to exactly one of those subsets in the partition. What does that mean? You can see that we have three elements in set A, right? What is the first element? 1. It belongs to what? Set B. Subset B. We have 2. It belongs to subset B. Then we have 3. So you see that we have every element in the given set belongs to exactly one of the subsets. Do you get that point now? But how about this now? If I have set Z equal to 2, 4, 6, 8, and then we now have subset A equal to 2, 4, subset B. Okay, we have this partition P equal to we have another one. Then we have another one. Then we have another one. Okay, I think. Alright, now let's look at these three partitions. We have set Z equal to 2, 4, 6, 8. Now let's look at these three partitions. Let's look at these three partitions. Okay, which of them, let me put that way, which of them is correct? Is a correct partition of set Z based on these three conditions. Now let's start with the first one. Now let's check whether it satisfies the first condition, that none of the subsets should be an empty set. If you look at it, none of them is an empty set. Okay, fine. It satisfies the first condition. Then Number 2, none of the subsets should have the same element in common. Let's check. None of them have any element. It's a second condition. Number 3, every element in the given set must belong to exactly one of those subsets in the partition. Now, every element in set Z must belong to one at least. You understand? Must belong to exactly one of those subsets in the partition. Now, is that true? Step 2, because we have 2 in the partition. We have 4, we have 6, we have what? 8. 2 and 4 are the element in the first subset. 6 is the element in the second subset. 8 is the element in the third subset. So we have all the elements in the partition. So it satisfies the third condition. That means this one is correct. It's actually partition of what? Set what? Z. Then let's look at the second one. Let's see whether it satisfies the first one. Yes, it does. There is no empty set. Then let's look at number 2 condition. It does not. It does not, because we have 4 appears twice. Because according to the second rule, the second condition, there shouldn't be any subset that have the same element. So this one is not. Then let's look at the third one. Does it satisfy the first condition? Yes. None of them is an empty set. Let's look at the second condition. Is there any subset that is there any subset?
No.
Are there
Check
subsets?
the first one. We have empty sets.
Very good. Very good. So you see that the last one does not satisfy does not satisfy the first condition, because there is an what? Empty set. We say that there shouldn't be any empty set. And if you look, so that is, because of that, it is not correct. So the correct one is the first one, based on the 3 conditions that we have enumerated. Do you get the point? So partition of sets is the collection of subsets of a given set such that the subsets are non-empty sets. We can also say that it is the breaking of sets into non-overlapping subsets. And since they are non-overlapping subsets, that means they are disjoint sets. Disjoint sets, 2 sets are said to be disjoint when they have no elements in common. So these are the 3 conditions by which we can say that the partition of a set is correct. So when these 3 conditions are satisfied, then we say that the partition of a set is correct. Alright.